Howdy folks, Mr. Reed here, and welcome to one more question. So what we're going to be taking a look at today is something called prime factorization. We're going to do it at a mild level, so I'm going to take a smaller number that's made up of nice small primes, and we're going to do that prime factorization. So if that's what you're looking for, let's get to it. Alright, so as you can see up above, what we're going to do is we're going to take the number 150 and we're going to do the prime factorization of it. Now, I have it's really one method that I prefer, but there's a couple different ways you can represent it graphically, and so I'll let you see what those are, and you can kind of pick and choose which one you think you like the most. Really, they don't do the question any different, the two methods that I'm going to show you. So first off, we can start out with the number 150, and I just draw a nice vertical line, and I'm going to start thinking about prime numbers that go into 150. So let's just start out by saying if you notice that the number's even, prime numbers that will go into that for sure would be a 2. So anytime you have an even number, you can start kind of picking your way through it like that. So we can go 2, and that would, if I divide that into 150, that would make the other factor that if I were to factor 150 into 2 times something, it would be 2 times 75. So that's where we're sitting right now. We got a 2 and a 75. So now I'm going to take that 75, I'm going to start to break that one up. 75 is not even, so 2 will not go into it anymore. But 75, it does have a 5 that will go into it because it ends in either a 5 or a 0 there. So we'll put the 5 into it. If I divide 5 into 75, I will get 15. So that would leave me with 15 as the value there that we're left with. Next up, kind of ask the same question there. Oh, 5 still goes into that. So 5 it is. And that will leave me with a 3, and 3 is prime. So what I'm left with in the end are these 4 numbers that if I were to multiply those all out, that will give me the same number that I started with. In this case, that would be 150. So 2 times 5 is 10, times another 5 is 50, times another 3 is 150. So we're at the right number, that's good. So if you're sitting there and you're like, okay, well that's no problem, but some of you might be saying, well, what is a prime number? So a prime number is a value or a number that only has 1 in itself as divisors. So what that means is if you were to try to factor a prime number, you would find nothing other than just 1, and whatever that number is will divide into it evenly. And to give you those factors. So if you had the number 5, for instance, 1 of course will go in, 2 does not, 3 does not, 4 does not, and 5 goes in. So 5 has 1 and 5 as factors, and so it is a prime number because just 1 in itself are factors of the number 5. So what you really want to do is actually take the time to come up with a list of some smaller prime numbers. It's really reasonable that once you get higher up, you probably don't recognize them, and that's going to be okay. But you really should feel comfortable with, for instance, 2, 3, 5, 7, and then it would go up 11, 13. So you should recognize some of those and feel like they are going to be kind of just a little bit off the tip of your tongue so that you are going to be able to recognize that those are ones you need to look for when you're doing a prime factorization. So in this case, I had a 2, I had 2 5s, and I had a 3. So if I were to write the prime factorization as kind of like an answer, after I found that list of 4, I could write it as 2 times 3 times 5 times 5. I could also choose to write that as 2 times 3 times 5 to the power of 2. So sometimes it's nice, especially if you have a larger group of the same prime, to express the repeated multiplication as an exponent or a power instead. So in this case, 5 squared is the same thing as, or 5 to the power of 2, is the same thing as 5 times 5. If that were like 7 5s especially, not that we probably would deal with that in prime factorization, that's pretty large number to get there. It would be a lot nicer to express that with a 5 in the single exponent than it would be to say 5 times 5 times 5 times 5 times 5 times 5 times 5 or whatever, if I said that the right number of times or not. So those are ways that we could express this answer. That's all there really is to it. The most important thing you can do is practice, get used to the prime numbers that are especially the small ones, and come up with a way that you're comfortable with. So as I said, I have another way to graphically represent it. I'm going to do the same question, and hopefully you'll feel like one of these two methods of organizing your information resonates with you. So let's go ahead and start it with that number 150 again. And so this one's more like looks like a tree, a factor tree. And in this case, instead of just always shooting for primes, I'm going to instead look for factors, any factors of 150. So the first thing I think of when I look at the number 150 is that it's a multiple of 10. So I'm going to put down 10 there and say, okay, well, 10 times 15 is going to give me 150. Whoops, 15. And then 10 is going to factor into 2 and 5, and 15 is going to factor into 3 and 5. So now that I'm down at the bottom, and I could, again, what's helpful at this point is recognizing small prime numbers. So I have a 2, prime, 5, prime, 3, prime, and another 5. So I again get 2 times 3 times 5 times 5, or 2 times 3 times 5 squared. All right, so those are a couple different ways you can organize the same information. It really isn't any different, those two methods. It's just how you like things to look and how you go about finding it. Whether you're just looking for any old factor or you're looking specifically for prime numbers that go into it, you're going to result in the same list of prime numbers in the end, which is known as the prime factorization of a number. All right, if you found that helpful, like, subscribe, and as always, take care, folks.